if I want to graph this one, well, it's got 5 transformations in it. There's a lot to keep track of here. And this method that I'm about to show you can be used for any of the ones that we did above if you can't see it right away. It's a foolproof method if you know how to do point-wise transformations. So, but you still have to look at this and try to understand it. So this is going to have an amplitude of 3. The axis is going to be at y equals 1. It's going to be vertically flipped. It's going to have 2 cycles between 0 and 2 pi, or a period of 2 pi divided by 2, which is just pi. And it's going to have a phase shift of pi over 4 to the left, because it's the opposite sign of this, so to the left pi over 4. Okay, that's a lot to keep track of. You can do that. You can graph 5 different graphs till you get to the last one by doing the stretch factors first and then the translations. Or you can do this pointwise formula. So from y equals cos x to f of x, which is this one here, we can figure out the pointwise formula by looking at what happens to x. Well, x is going to be horizontally stretched by a factor of 1/2 and then translated back pi over 4 units. Y is going to be multiplied by -3 because it's being vertically stretched by -3, and then translated up 1. So this becomes the formula. 1/2 times x minus pi over 4, so taken as the opposite of what it seems. And then for the y, you take it directly, -3y plus 1. So now you've got this formula, and you can apply that to all the key points of the cosine function. So the key points of the cosine function are these: 0, 1, pi over 2, 0, pi, -1. So just by looking at the graph, you look at these key points, okay, every quarter period. You apply this formula to it. So 1/2 times 0, that's 0, okay, minus pi over 4 gives you negative pi over 4. And then -3 times 1 is -3, plus 1 is -2. So there's one point. That point became this point with these transformations. Same thing with those other key points. You get these. Now you plot them all. And when you plot them all, you get one cycle of the graph. And then you have to fix it so that it fits in between 0 and 2 pi. Okay, so one cycle of the graph, well, it's not quite there. It's basically there. Okay, so one cycle of the graph, you plot the points. There's the first one, negative pi over 4, and that point, and then 0 and 1, and so on, and you got these points here, and that's one cycle. You don't want it less than 0, so I just left the point there, and I kept following the pattern. And then I finish it at 2 pi, and you've got the graph. And then you check, does it have the properties that I was looking for? Okay, so look at the original function. Does it have an amplitude of 3? Yes, it does. Okay, does it look like it's been flipped? Well, from here, it did. Okay. Does it look like it's been has 2 cycles between 0 and 2 pi? Yes, it does. Has an axis of y equals 1. Yeah. And looks like it's been translated pi over 4 to the left. Yes, because the first point was over here. And that's how we do more complicated ones. This method works for any of them, though, even if you want to apply it for simple ones. Okay, another example that I have here for transformations is a transformation of the tan function. So for this one here, we've got 2 tan pi over 4 x minus 1 plus 1. So it's been vertically stretched by 2, horizontally stretched by 1 over pi over 4, which is 4 over pi, translated to the right 1, and so we got to put this all into a pointwise formula, figure out what our key points are. So we're going to take the reciprocal of this, so 4 over pi times x plus 1 is going to be the x coordinates, and then the new y coordinates are going to be 2y plus 1. We're going to apply this to key points from the tan graph. Now the tan graph looks like this. Okay, just a reminder, it's like that. And like this. Okay? So at this point here, pi over 4, we've got the value of 1. We've got 0 there, 1 there, and then at pi over 2, we've got an asymptote. If we get this piece transformed, then we can translate that to the other ones. So let's look at those 3 key points, and how are we going to label those? We're going to do 0, 0. Then we're going to do pi over 4 and 1. And then we're going to do pi over 2. And a vertical asymptote has no y coordinate, so I'm just going to put a dash there to represent every y value. It doesn't matter what the vertical transformations are of a vertical asymptote, because you stretch it or move it up or down, it doesn't really change it. You want the horizontal transformations of a vertical asymptote. So these formulas, well, you apply 0, 0 to this formula, you're going to get 1, 1. Pi over 4 to that formula, so pi over 4 times 4 over pi is just 1, and 1 plus 1 is 2, so you get 2. Plug that in there, and you get 3. Okay, and for this one, pi over 2 times 4 over pi plus 1 is going to give you 3. And it doesn't matter what the y is for that. So that gives us this point, and this asymptote transformed. Okay? So let's draw the graph. Okay. And another thing that we want to look at is, what is the period? So the period of this graph, there's pi over 2, there's 3 pi over 2. The period of this tan function, remember, is pi. It's not 2 pi. So the new period, so t equals pi over k, over the absolute value of k actually, and k is pi over 4. So we're going to have t equal to pi over 4, which just ends up equaling 4. So in 4 units, it goes through 1 full cycle of the tan graph. Okay, so first point we're going to plot is 1, 1. And the next point we're going to plot is 2, 3. So 2, 3. And then the next one is going to be at 3, and that's going to point. That's the vertical asymptote. Okay. So we moved up everything 1. So this becomes this thing here. Okay. And then we go over, it's a period of 4. So on this side, it's going to be down here. Okay. Go like that. And you're going to have at -1 another vertical asymptote, because the period is 4. It's going to look like that. So that would be 1 cycle. And then for the next cycle, because this is at 3, it's going to end at 7, 4, 5, 6, 7. And you're going to have the same sort of idea. You're going to have that center point there. And then at 5, or at 6, it's going to be 3. And over here, it's going to be down here. Down 2. And look like that. And that's a transformation of a tan graph.